Hey guys, last video, 36 and 37. Let's do it. Woohoo! All right, the learning goal says apply the concepts of density to area and volume. For example, a person per square mile or BTU per cubic foot. So if we look at our cheat sheet, there's a little something on here about density. The formula that they don't provide, but that helps if you memorize, is the density is equal to M over V. So the director of the school is Mike Viggio, okay? Hopefully that'll help you. We usually call him the principal, but you could think of him as the director of the school, Mike Viggio. That's the formula. So let's try this out. You can also remember it's usually the person or the mass of some sort, and then the volume or the area, okay? Notice how this says cubic foot per cubic foot, so you know that goes on the denominator. So I actually use, instead of a formula, the labels to help me. So the average classroom measures, right, it's a cube, 20 by 30 by 10. Okay, that makes sense. So what would be the volume? Base times width times height, right? 30 times 40 times 10. So that'd be 6,000 feet cubed. The maximum capacity of a room this size is 45 students. So how many students? The density would be measured in students per foot cubed, right? Or cubic feet. So I'm going to do 45 students, right, over the volume. And I'm going to come up with an answer. 45 divided by 6,000, we get 0.0075. And again, my label is in students per cubic foot. Okay. Question number 2, Amy bought a candle in a very unusual shape. The base and the top of the candle are congruent triangles. Okay, so that means it has to be a prism. So the top is some type of a right triangle, and the bottom is some type of a right triangle, and they're the same. Right? So the top and the bottom are the same. The dimensions of the right triangular base are 6. All right, so the volume of anything in the universe is the area of the base times however high you stacked it. All right, so we stacked this right triangle a height of 10. So the volume would be the area of the base times the height. Well, the base is a triangle, 1/2 base times altitude, right? And then we're going to have our height. So our volume, they said, the volume is what they want us to figure out. So 1/2, and we can call this base 6, and we could call the height, the altitude, right, 9, and the height is 10. So we get 10 divided by 2 is 5. So we get 6 times 9 times 5. 270. Instead of doing this canceling method, you could have also just put all the numerators in the calculator and all the denominators. So that's a shortcut that many mathematicians use to make the answer go faster. So just want to make sure that you notice the shortcut still gives you the same answer if you didn't understand what I did there when I crossed out the 2 and the 10 and wrote a 5. Okay. Question number 3, County X has a population density of 250 people per square mile. So the density is measured in people over miles squared. Right, so 250 people per square mile. The total population of the county is, and this is measured in people, right? Which geometric model could be the shape of the county? A parallelogram with a, that was weird how I drew that. A parallelogram with a base of, let's see. So this is DMV, right? We're trying to, or you could also show this as the area. So let's see. If I wanted to solve for area, you could swap these, right? And put this. So if I know I have 150,000 people, and I know my density is 250 people, I actually like to show it like this, 250 people for every 1 mile squared, then notice I can get my answer in miles, which is what I'm trying to figure out my area here, right? So I'm going to divide by 250, and I know that this town has to be 600 miles squared. And we can double check this. You can plug this back in. Is this amount of people divided by 600 miles squared going to give me that density? $150,000 divided by 600 is 250. Yep. So that we know works. So which of these would have the area of 600? Okay, so which of these? A parallelogram would have an area of base times altitude. So 25 times 25. 25 times 25 is 625. So I'm going to have to say no. A rectangle 15 by 45. So that would be 15 times 45. I get 675. So I'm going to also have to say no. A right triangle with a leg that is 30, and a hypotenuse, which is 50. Oh, that's our famous 3, 4, 5 triangle, right? So that would be, the area would be base times 1/2, base times altitude. So 1/2, 30 times 40. Ooh, I think that's a yes, right? Because that would be 1,200, which is 600, and that's what we're looking for. Okay, the last one is a trapezoid with a base leg of 10 and 30. So it's a confused rectangle. And a height of 25. So to find the area of a trapezoid, we take the average, so we add the two bases together, divide by 2, and then multiply by the altitude. So its average width is 20, and 20 times 25 is 500. So this is a no. Again, feeling even better that with our answer being C. Cool. Okay, question number 4. Given the size and mass of each solid cube, so here's our cube, and the word cube means that this would be 1 centimeter and this would be 1 centimeter, because cube means all sides are equal. Given the size and mass of each, how many times is the density of cube X greater than the density? So how many times is the density of cube X greater than the density of cube Y? Okay, so the density would be this. The director is Mike Vigio. The density would be this mass, 4 grams, over the volume. And the volume is 1 times 1 times 1, or 1 centimeter cubed. So that's our density for our first one. What's the density of our second one? Same formula, right? But now our mass is only 2 grams. And our volume would be 2 times 2 times 2 centimeters cubed. So this will cancel, and we get 2 divided by 8 is 1/4 centimeters cubed. So this would be 0.25 centimeters cubed. Now to compare, you have to take the big one over the little one. So the big one over the little one, 4 grams per centimeter cubed over 0.25 grams per centimeter cubed is what? I get 16. So this one is a big, you could think of this as like maybe a bar of soap, and this is a bar of gold. It's much denser. So even though the soap is bigger, it's a lot lighter. So it's 16 times denser, the gold is, than the soap. Awesome. Last page. Let's dig in. It says, apply a geometric method to solve some problems. So you might be looking at ratios, anything physically constraining my shapes. It says a package is a rectangular prism, and it has to be mailed. For this package to be mailed at the standard post rate, the sum of the length of the longest side and the girth, which is its perimeter around the other dimensions, must be less than or equal to 108. Figure 1 shows how to measure the girth. Okay, what is the sum of the length in inches of the longest side and the girth of the package? Okay, so we know this length matches this length because that's a rectangle, right? So we have our length plus our girth. So we found our length already is 42. Now our girth is this plus this plus this plus this. So we see these numbers here. This would be 19, this would be 11, this would be 19, this would be 11. So our girth and they want us to add that together. And we have 102 inches. So it has to be less than 108, so it looks like this can ship. Why? Because 102 is less than 108. Kind of neat question. Okay, this container is composed of a right circular cylinder and a right circular cone. Which is closest to the surface area? Okay, so I don't anticipate kids being able to memorize these formulas, but you know what? So maybe you skip it, but I'm still going to work through the question because I'm a math teacher, right? The surface area of my cylinder is my rectangle that goes all the way around. Think of it as a label I wrap all the way around. So the surface area of just this outside part, if we think of it as a barn, how much would I have to paint, would be the circumference, which is 2 pi r, and then a height of 10. So that would be my base and my height. I could also think circumference is just pi times diameter. So my circumference here would be 24 pi, and my height is 10. So I have my area there, my surface area of, and I wouldn't paint the bottom. It looks like they just want the surface showing. So that would be 24 pi times 10, which would be 240 pi. So I'm going to take 240 times the number 3.14. I get 753.98. Okay, so neither of these can be the answer because, well, hold on, none of these can, because then I also have the surface area of this top part. So in a way, they did me a favor. I didn't even have to memorize the surface area of a cone, but let's get the surface area of a cone. I think I've got it here somewhere. The surface area of the cone is the bottom part, right? But they don't want the bottom part. And then this part along the side is this pi RL, and we have to know this length. Pi RL. Okay, so back to our problem. The surface area of the cone is this pi RL, and they gave us this L. That's very nice of them. So pi times our radius, don't fall for that, right? Our radius is 12, and L is 13. So let's figure out what that is. 12 times 13, right, times pi. We get 490.09. If we add that to our 753, we get, 1244. So yeah, pretty darn close to what I got. Nice work. All right, question number 3. A farmer wants to build a new grain silo. The shape of the silo is to be a cylinder with a hemisphere on top. With the radius of the hemisphere is to be the same length as the radius of the base. So that and that are the same. Okay. The farmer would like the height of the silo cylinder portion to be 3 times the diameter of the base. Okay, so I actually come from what's called corn country, and this is exactly what silos look like. They're very, very tall and skinny, and they have a circle at the top. So they want, whatever this diameter is, they want this to be 3 of those diameters. Okay? What should be the radius of the silo if they wanted to hold that many cubic feet of grain? Okay, so this is a very complex question. So let's work it out here, one piece by piece. So the volume is the cylinder, right? Plus my hemisphere. So my sum is the area of my base times however I stacked it, and my hemisphere, instead of 4/3 pi r cubed, is 2/3 pi r cubed. So we find that the volume is this number, right? Our radius we're solving for. Our height is, let's see, 1, 2, 3, 4, 5, 6 radiuses. So 6 times the radius is my height. And then I have 2/3 pi radius cubed. So I'm going to do a little bit of algebra here. Hopefully I won't scare you off. All right. Oh, wait. Before I do that, notice I have a pi on every term. So I could divide by pi on every term and it will go away. That's probably a good thing. Make this thing go a little faster here, right? 22500 is equal to 6 times r times r times r, so 6r cubed, plus 2/3 r cubed. So I really don't like this 3. I can multiply, just like I divided everything by pi, I can multiply everything by 3 to get rid of that. That would be a nice trick. So 22500 times 3, 67,500. And 6 times 3 is 18. And these would cancel, so or 3 times 2 is 6, divided by 3 is 2, so it would get 2 radius cubed. I copied that down wrong. So this combines to make 20 radius cubed, and now I can divide by 20 on both sides. So 67,500 divided by 20. So 3375 is equal to the radius cubed. So I have to take the cubed root of both sides. My calculator lets me do this, so I'll let you in on how I would do this. So if I go to my calculator screen, the cubed root of 3375, so 3375, and then I actually have a calculator button like that, so it says 15. So radius is 15. On the green calculator, you would hit second y to the x. And so you'd put in the number 3375 and then second y to the x, and then hit the number 3 to tell it what root you would want. But you have to hit second to get that cubed root. All right, and my answer is 15. Okay, last question ever. Really, really exciting. Lewis is going to form a clay model of a skyscraper. The model is to be in the shape of a 2-foot tall prism with 6 inches by 6 inches on the base. The clay he will use in the container describes below. What is the least number of containers Lewis will need in order to complete the model? Okay, so we need to find the volume of each. And these are in feet. So I want everything in feet. So this, I'm going to change this to 0.5 feet. And 6 inches is 0.5 feet, right? So I want to find the volume, base times width times height. So 2 times 0.5 times 0.5, 2 times 0.5 times 0.5. We get 0.5 feet cubed. Okay, so that's what our skyscraper needs to be. So let's find out how many of those are in this container. So containers are a 1/2 foot tall, so that's 0.5. And the cylinder shaped with 1 foot diameter. So that means the radius is 0.5. Okay. So the volume of my cylinder is the area of my base times my height. So 0.5 squared times my height, 0.5. So it's really 0.5 times 0.5 times another 0.5. And then we'll multiply by pi. Okay, so I get 0.3926. So now we take the volume of our prism and divide how many of these cylinders are in there. So we take 0.5 and we figure out how many go in there. And I think we can see this, but I'm going to go ahead and go through with the math. And I get 1.27. So I almost can make this model with 1 container. I need 2 containers because I'm short, right? I need 0.5 and I only have almost 0.4. So I'm going to need 2 full containers to finish my model. Great job, guys. I'm so proud of you. Congratulations.